Hi everyone. Currently when we move forward and strafe left or right, there are issues with the blending which cause the legs to skip. The same problem happens when we try to move backward diagonally. Today we will address this common issue in locomotion systems by adjusting the character's hips while moving. Additionally, we will explore Animation Notifies in Unreal Engine to resolve the foot sliding issue when a character lands. We'll start by addressing the foot sliding issue that occurs when the character lands on the ground. While this issue isn't very noticeable when a player is just running, it becomes much more apparent and problematic when the player sprints, jumps, and then lands. To understand why this foot sliding occurs, let's revisit the main animation blueprint. We previously set up the jumping sequence with 3 states: jump start, jump apex, and jump pre-land. The character lands in the pre-land state, and once that animation finishes, it transitions to an additive animation clip called jump recovery additive, which returns the character to the idle pose. The problem arises during this transition, causing the foot sliding. Initially, I tried to solve this by speeding up the transition, but the issue persisted. Instead, we'll fix it by modifying the friction and braking deceleration values to something very high at the first frame of the jump recovery animation to stop any foot sliding. To execute custom code at a specific frame, we can use Animation Notifies, which allow us to send and receive events synchronized with animation sequences. We'll create a custom animation notify in C++, write the code necessary to stop the foot sliding, and then call this animation notify in the jump recovery animation. Let's start by creating a new C++ class of type animation notify, name it something like modify land state, then hit create, and open Visual Studio. In the header file, we'll begin by overriding a virtual function called notify, which has the skeletal mesh component as a parameter. This component allows us to obtain a reference to our main character class, giving us access to the movement component. As usual, let Visual Studio generate the definition and then open the corresponding .cpp file. At the top of the .cpp file, ensure you include both the main character's header file and the character movement component. Inside the notify method, which we've overridden, we'll start by calling the getOwner method on the mesh component. This method returns an actor, so we'll cast the result to our main character class. To ensure the cast succeeds, we'll use the isValid method. If the cast is successful, we can grab a reference to our main character class by casting the result of the getOwner method again. Then, for the braking deceleration walking, I'll set its value to something quite high, such as the multiplication of the current max walk speed by 5, and set the ground friction to around 20. These values work well for my setup, but feel free to experiment with them to find the best values for your character. Once you've made the changes, compile the code and return to the editor. Open the Jump Recovery Additive animation, select to the first frame, right-click, and select Add Notify. Then choose Modify Land State, which should be listed first. That's it, save the animation clip. Now let's test this together. Hit Run, and press Shift plus F1 to eject from the player view. In the outliner, select the BP_main character instance, and in the Details panel, search for walking to observe the values when the character lands. Excellent! You can see the values change correctly, eliminating any foot sliding issues when the character lands, even during sprints. Additionally, because we set the walking and sprinting attributes in the main character class, the values automatically adjust based on whether the player is sprinting, so there's no need to reset them manually. Now let's dive into the main topic of this episode, diagonal movement. When the character strafes to the right while moving forward, or to the left while moving backward, the animations don't blend smoothly, leading to a foot skipping issue. One way to handle diagonal movement is by using dedicated animations for 45-degree angles during forward and backward running. However, since we don't have those specific animation clips, we'll use another common solution. When the player moves diagonally, we'll rotate the hips in that direction and play either the forward or backward animation clip, depending on the direction. This method is smooth and widely used, and you'll love the final result. Let's get started. Let me show you how we'll achieve this using the character skeleton. When the player moves diagonally, we'll rotate the hips in that direction, which means rotating every bone from spine 1 or spine 2 downward. At the same time, we want to keep the upper body unaffected by this rotation, so we'll rotate every bone above spine 1 or spine 2 in the opposite direction. This approach creates a more natural-looking movement. It shouldn't be difficult to implement since we already have the movement yaw delta value from previous episodes when we set up strafing. We'll use this value, which is the difference between the character's movement rotation based on its velocity vector and the base aim rotation, the rotation of the controller, to rotate the hips accordingly. We'll implement this in the main anim instance blueprint class, so go ahead and open it up, and let's get started. Currently, we have the cached locomotion connected to the turn-in-place pose, which then feeds into the control rig node and finally to the final pose. However, we're going to modify this setup based on different conditions. For now, let's move this down a bit to create more space. If the is-in-air boolean is true, we play the locomotion pose, otherwise, we use the rotate root bone to handle turn-in-place. This setup worked fine before. If the character was idle, we play the turn-in-place animation, and otherwise, we go back to the locomotion pose. But now, since we need to support diagonal movement, we must be able to choose which pose to play based on specific conditions, which we'll discuss shortly. But first, let's start by rotating the hips for both forward and backward movements. We'll begin with the locomotion pose, which is the pose before any turn-in-place functionality is applied. First, copy this pose, and then let's add a rotate root bone node to rotate the hips. As before, we only need to focus on the yaw rotation, so we'll leave the other pins hidden. Keep in mind that rotating the root bone will rotate the entire character, so we'll need to counterbalance this by rotating the upper body by the same amount but in the opposite direction, starting from spine 2 and above. To achieve this, we can use the Modify Transform Bone node, which is very useful in this case. We only need the rotation pins, so remove the others and set the rotation mode to Add to Existing. Drag from the Rotate Root Bone pose to the component pose. This will automatically create a new node called Local to Component to connect to the Modify Transform Bone node. To rotate the upper body in the opposite direction, we'll simply take the same movement yaw delta, multiply it by -1, and then create a rotator to apply this value as the rotation around the yaw axis. We'll connect this rotator to the rotation pin on the Modify Transform Bone node. Next, we'll cache this to a new pose and rename it something like Cached Locomotion Forward Turn Hips. However, before connecting the output of the Modify Transform Bone node to the cache pose, we'll need to use another node to convert from component pose to local pose. You might notice that the Modify Transform Bone node gives us a warning. This happens because we haven't yet specified which bone to modify. In the Details panel, select the spine_02 bone, which is slightly above the waist. This setup works well for forward movement, but when the player tries to move backward while strafing left or right, we'll need to make some adjustments since the movement yaw delta will be around 180 degrees. In diagonal movement, the rotation angle is about 45 degrees, which works fine for forward movement, but for backward movement, we need to add 180 degrees to the movement yaw delta to ensure the 45-degree angle is considered in all directions. We'll set a threshold value for the degrees in the code shortly. For now, let's copy all these nodes and make the necessary changes. Drag from the movement yaw delta pin and choose an Add node, then add 180 degrees and reconnect it. We'll do the same adjustment here since we need to rotate the upper body by the same amount but in the opposite direction. Finally, let's cache this pose and name it Cached Locomotion Backward Turn Hips. Now that we have two cached poses, one for turning the character's hips when moving forward and the other for when moving backward, we need to determine when to play each one. We also shouldn't forget about the turn-in-place pose. But before we do that, let's address a potential issue that could arise. When moving diagonally in the backward direction and the player suddenly releases the movement input, the hips might rotate more than 180 degrees. This happens because the movement yaw delta will reset to 0. If you recall, we encountered a similar issue when implementing the run-to-stop animations, and we resolved it by saving the last frame and renaming the variable to last movement yaw delta. Let's do the same thing here. We'll quickly replace the movement yaw delta with the last movement yaw delta for the backward direction to prevent this problem. To determine which pose to play, whether it's the forward turn hips, backward turn hips, or the turn in place, we'll need some Boolean variables to control this. Let's open Visual Studio and add these variables to the main anim instance class. Scroll down, and we'll place them at the end of the class. For now, let's create just one Boolean variable to determine if we should play the forward turn hips pose or not. We'll handle the backward movement later, as it involves more complexity when dealing with diagonal movement. We'll add a U property macro to this variable and categorize it under turn hips. At the end of the native update animation method, let's set the flag for playing the forward turn hips pose. We know that this should occur when the character is moving forward and strafing either left or right, which means the movement yaw delta should be less than 45 degrees. To make the locomotion system more responsive, we'll increase this threshold slightly. 55 degrees is a good value. We'll take the absolute value since we need to account for 45 degrees in both directions, left and right, and the player must be accelerating, which we can determine using the B as accelerating flag. After making these changes, compile the code and return to the editor. In the Animation Instance Blueprint class, we can use a blend pose by bool node. By using the should turn hips flag, we can determine whether to play the current locomotion with turn in place pose or the locomotion forward turn hips pose. It looks like I have declared the should turn hips as a float variable, not a boolean. Let me quickly fix that. If the should turn hips flag is false, we'll play the turn in place pose. Otherwise, we'll play the forward turn hips pose. To ensure smooth transitions between poses, we can change the blend time for both poses. I played with these values and I found that 0.25 is a good value. For testing, connect the result of the blend poses by bool node directly to the control rig node. Observe that when moving diagonally in the forward direction, the hips rotate correctly, and the upper body follows suit. We also need to ensure that when rotating the hips, the forward animation clip is played to achieve natural movement. Open the running blend space. Currently, we don't have a slot available for the diagonal direction in the view. In the asset details, for the horizontal axis, let's increase the grid division to 8. The jog forward animation is in the center. We should also play the jog forward animation on the right and left of it. For leaning, we will play the jog forward circle to the right when the lean value is 90 and to the left when the lean value is minus 90. Essentially, we added a jog forward animation for values that are approximately 45 degrees. For leaning, we kept them the same as before, as all we did was expand the jog forward area. While experimenting, I have also reduced the smoothing time to 1.2. I found that this is a better value, because I wanted the transition to happen a little quicker. Now let's give it a try and see if it looks better than before. Awesome! Now when the character plays the jog forward animation, the hips are turning correctly, and the leaning is smooth when the player moves diagonally. However, nothing has changed for backward movement. Let's address this by first filling in the empty spots in the running blend space before writing any logic. Starting from the right, we'll adjust the jog backward and leaning values to something like 135 degrees to trigger them sooner. This won't completely solve the skipping issues when moving backward, but it will help in certain angles. We'll do the same thing for the left side as well. Since the current setup doesn't resolve the skipping issues that occur at certain angles when moving diagonally backward, we need to address this issue differently. What we can do is create a new simple blend space specifically for the jog backward animation. Additionally, we can include both the right and left leaning animations. In the blend space folder that we previously created, let's create a new blend space and name it something like running backward blend space. I've already done this, and I'll now show you what I did. As you can see, it's quite simple, with only one axis representing the leaning value, ranging from minus 90 to 90, with a smoothing time set to 1. In the center, we have the jog backward animation. On the far right, there's the lean right animation clip, and on the far left, there's the lean left animation clip. Now, save it, and before we head back to the animation blueprint asset to connect this, we still need to determine when to play the running blend space and when to transition to this backward blend space. While playing this backward blend space, we also need to play the backward turn hips pose. Let's open the Anim instance class to create a flag to control this state. Simply copy these lines and change the flag name to something like B should run backward. The should run backward flag should be set to true when the movement yaw delta is near 180. However, we also want the locomotion system to support diagonal movement and be more responsive, so we can select a value such as 125. Additionally, the player should accelerate. Let's open the run state and the ground locomotion state. Previously, we only had the running blend space. Now, with the backward running blend space, we need to blend between them based on the should run backward flag. We can use the blend poses by bool. If the should run backward flag is true, we transition to the running backward, otherwise, we transition to the running blend space. For the running backward, we only need to use one single value, which is the linear delta because we only use this single axis. Finally, we have to determine when to play the backward turn hips pose. Let's return to the main anim graph window. The first blend poses by bool node determines whether we should play the forward turn hips or the turn in place pose. The result of this pose can lead to another blend poses by bool using the should run backward. If the should run backward boolean is false, we can take the result of the two poses, the forward turn hips, and the turn in place pose as they are. Otherwise, we can then transition to the backward turn hips. I will change the blend time for the second blend pose node to something like 0.2. It's recommended to experiment with these values. That should be it. Let's give it a try. Everything looks fine. The hips turn exactly as we specified. However, the transition from the running blend space to the running backward blend space is not as smooth. Also, we have this glitch when we suddenly move from backward directions to forward. Let's quickly fix these issues. To fix the glitch issue that occurs when we suddenly move from backward directions to forward and vice versa, we need to make some changes. When using the blend poses by bool nodes, we will change the transition type from standard blend to inertialization. Additionally, we will use the inertialization node for all the blend poses by bool nodes. We also need to make the same changes in the run state. Now the animation's transitions are much smoother. However, the transition to the backward animations is still not that smooth. To address this, let's change the blend time for the blend poses by bool node in the run state. I will choose a value of 0.25. When moving diagonally, the locomotion system feels more natural and responsive with leaning and hip turning. We won't be making any more changes to the locomotion system for now, but we could improve it further by adding pivoting. Currently, if you try to strafe right and then suddenly change direction to strafe left, the transition looks bad because there are no animations to handle such a wide change in direction. This applies to other directions as well. Fortunately, the Paragon character asset includes these types of animations, which can be found in the Paragon Animations folder by searching for pivot. I won't cover this system now, but I plan to do so in the future. In the upcoming episodes, I will cover the implementation of a dynamic aiming system using aiming offset and inverse kinematics for hands placing on the weapon. I will only cover the animation system and the IK part, but not the actual shooting mechanic, since the shooting mechanic is a separate topic. After covering the aiming system, I plan to discuss motion matching to implement a locomotion system. I'm still studying this concept, but I'll be using the Unreal Engine game animation sample, which contains hundreds of AAA quality animations. For now, that will be all from me. Thank you for watching, and see you soon.